So this topic name is called Computing Conditional Probability to Make an Inference Using a Two-Way Frequency Table. The question here says a group of 200 patients tested a new medication. Some tried the new medication and the rest took the old medication. The results are reported in the following two-way frequency table. By the way, just so you know, it's called a two-way frequency table because you need to pay attention to the rows and the columns. So just as an example, everyone in this column showed improvement, some taking the old and some taking the new. Everyone in this column showed no improvement, some taking the old, some taking the new. And then if we kind of undo that, think about it a different way, everyone in this row took new medication with some showing improvement and some not. And everyone in this row took the old medication with some showing improvement and some not. So we've got several different things happening here. I'm going to get rid of all that, and so we gotta interpret this this two-way frequency table to understand these probability questions. So the first part asks us. So it says a patient is chosen at random from this group. And so the first question says, what's the probability that they just showed improvement? So you look at it and say, well, there were 27 and 37. Adding those two together, you get a total of 64 that showed improvement. So just 64 showed improvement of any sort. And there were a total of 200 patients. So the probability of just showing improvement is 64 out of 200. We're supposed to write our answers as decimals, so we do a little division there. 64 divided by 200, you get 0.32. And so that's the first one. The second one says, the second part says, the way you interpret this notation, this vertical line means given that. So in other words, what's the probability that they showed improvement given that they took the new medication? So we need to narrow this down to how many people took the new medication. So the new medication is this group. So adding that direction, 27 plus 63, 27 plus 63, that is 90. So there are 90 that took the new medication. So 90 total took the new. So now what's the probability that they showed improvement given that they took the new medication? So of those 90, 27 showed improvement. So now I'm just looking at 27 out of 90. So how many showed improvement given that they took the new medication? That was the 27. And so that's 27 out of 90. When you divide that, 27 divided by 90, that's 0.3. And so now the interesting question is there evidence that a patient who takes the new medication is more likely to show improvement than a randomly chosen patient? So it's randomly choosing a patient. What's the probability of getting improvement at all? Is 0.32. If they took the new medication, what's the probability that they're showing improvement is 0.3. So those are actually very close to one another. That's why when you look at your options, oops, scroll down just a little bit. Look at your options. Is there evidence that a patient who takes the new medication is more likely to show improvement than a randomly chosen patient from the group? No. Now you got to look carefully. No, because they're about the same. So for this particular question, and yours might be different, because these two are about the same, there certainly is no evidence to suggest that someone taking the new medication is more likely to show improvement than a randomly chosen patient from this group.